You are going to find a door that's got rusted out panels, complex shapes that are hard to make. Don't be the guy who fills it full of fiberglass resin or body filler. You're better than that!
I'm watching this anyway.
In today's video, we're going to be working on a 1949 Willys truck door. A lot of these doors are all rusted out. They've got all these complex beads in them and a lot of different shapes on the backside. Today we want to break down how we dissect making different shapes, one tool versus another, and give you guys a lot of options on how you're going to replace your door, because some of those aftermarket patch panels don't even remotely line up to what you actually have. For this project, we're going to be using 18 gauge cold rolled steel. You don't want to use hot rolled. It has a scaling on it. It doesn't really like to be ground on. And cold rolled is much more malleable. This is a AKDQ. It's a more for actual shaping. And the good thing about it is we are actually matching it to the same gauge that the door already existed with. We're going to use the calipers so we get an exact measurement of the thickness of steel, which is 45 thousandths of an inch. When doing that, we're going to be using a TIG welder in today's video. You can use a MIG welder. We will get over the differences between the two and why you would want to use one versus the other. We're going to be using some compass separators for actually scribing and being very detailed with our measurements from one body line to another or a break in the metal. We're also going to be using a profile gauge to take an exact replica of our beads, the spacing, and then we have a bead roller that we're going to be replicating these beads in the bottom of this door to be able to make this patch panel seamless to where you will not know that this was an aftermarket panel. A lot of the aftermarket panels that we see are just very loose put together. They don't even come close to lining up with one another. They actually handed that to me with the door, and I just told them, you guys can keep it. It's not even going to fit. For this particular door, we have rusted out lower sections, and the section actually creeps all the way up into the very lower bead. It doesn't go into all three, only the lower one. And then when you open the door on the inside, you have the bottom tray of the door that is completely rusted out as well. There are areas that are savable, and we'll get into that. Like one side of the door is completely fine and we saved it, but then we have to make the lower patch on the other end of it. When I was assessing the door on what damage do we actually have to fix, we have rust in the lower door on the front side and on the inside of the jamb. And on top of that, the beads in one section of the door are actually pushed in where maybe they sideswiped something, and I need to get back access to be able to bring those beads back up. In order to fix the rust and the bead issue, we're going to be taking this into the first bead at the bottom section. There's 3 beads, and we're going to be replacing half of the bead. That way we have access to push the bead where it's sideswiped up, and we're actually getting rid of about 90% of that damage when we do our patch panel to even begin with. Before you get to cutting into your door, I want you to think about making the pieces before you've actually removed it. What does that length need to be? For example, the bottom of this door had a big door gap. We want to extend the door ever so slightly to take care of the gap instead of having to weld the entire perimeter. We still have to gap this door at some point. But at least if we can get the bottom of the door close, it's going to require minimal welding and grinding on the edge of the door to keep that consistent. When you normally gap a door, you might be using the edge of a TIG rod to lengthen it, and you would have to do that several times. If we can account for that distance before we make the panel and cut it off of the door, it's going to be much more accurate. If you were to cut it off of the door, you are going to be dealing with the thickness of your cutoff wheel or the thickness of your blade when you cut it being too loose or too shy. Pre-planning, the fitment needs to be spot on. If you don't get your fitment really good and you're using markers, which you can use markers, but again, are you keeping track of, are you grinding up to the Sharpie line? Are you grinding to where the Sharpie disappears? These are all mental notes that you need to keep consistent so that way these beads fit exactly where they need to be. The reason that it's so critical with this particular door is because I don't have a pull max yet that can actually stretch and force the beads into the door and just remake the whole piece. That would be the ideal situation. For this particular project, we're gonna split up into the very first bead right smack in the center. And how we're going to do that is we are going to be using a Lazy bead roller. You guys can use all different types of bead rollers, even if it's a hand crank bead roller that's on the cheap. But you just need to be making sure that you match up the radius to the actual bead, because those have very pronounced body lines at either end of that bead. It's not a very soft bead, it's a very tight bead. And so if we're talking about a hairline of a body line on that bead, you need to get those lined up exactly where they need to be, because if you're off just a little bit, you are going to have things be just a little bit off here, there, and everywhere. And when you actually get to do your body filler, it's going to be a battle the entire time. In order to get your distance, we are going to be using these adjustable wing compass. I don't know what the heck you call these. Normally I call this a compass, but Amazon sees otherwise. They give you some cheapy little thing with a pencil, not a 1/4 inch thick compass. So check the description if you guys want some of these. It's like a scribe and a compass all in one. But this thing will give you an exact measurement of, if you want to lengthen the door, you can do it while it's still on the truck and move these separators out exactly where you need it. Now we have the ability to actually take our bead measurement and add all of these up. The flat all the way to the bottom of the gap. We need to take into consideration the flange that's going to be tipped around the door. Add all of that up and then shear off a nice rectangular piece. You guys can hand cut these. Again, it's just being consistent. I find that if you have a shear and you have a way of making it exactly straight, even if it's a straight edge and you grind it flat, now you have something that's easier to square up, especially if you're going to be running this through the bead roller, putting the bead through there, because you want to lay your new patch panel over the piece before you remove it. That way you have the ability to take a scribe and make a very fine mark to where you are grinding right up to that scribe. The number one hardest thing with TIG welding sheet metal is fitment. 90% of it is fitment in my opinion. So if you can get that gap to where there isn't a gap and you are butting metal directly up to one another, this process is going to be a lot easier for you guys to just work through it than battle gaps and blowing holes and having body lines be off. Being precise with every step of it, if it means that you're making a template or it means that you're making an accurate measurement, it's key. After we've sheared the panel to size, the first thing that we are going to want to do is run the bead through. So I made the panel a little bit longer than I need, so that way I could get the entire profile of the bead pushed all the way through, and then what we would do, just trim it right smack in the middle. The reason that we chose to do it in the middle was because it wasn't exact on how much that this actually puts the shape in. So a bead roller is forming metal, meaning it is putting the curvature in two directions, versus say a pull max that is a reciprocating hammer and it's actually stretching the metal into the shape. You're not going to get quite the bead depth that you're going to get with a bead roller as you would with a pull max. So the reason that we're going to do half is because if we already know we just need to get it as close as we can with the tools that we have, we cut it in the middle. We're only using one of the sides of the bead that we have to line up and massage. With the fact that the door is still intact, we can then take that bead, run it through the bead roller until we are happy with what the profile gauge is showing us for depth. At that point, check the area of the bead that has the best shape with no damage, and you can get your depth for the bead to be exact where you need it to be. Once you cut that bead in half, you're going to be laying it over the door, and we're using a Clecos to hold and fasten it into the exact same spot every time. Now you have to take into account the distance that the sheet metal is going to move, and if that means that it's going to go up when you remove the bottom of the door, or it's going to drop into the door laterally, you're not going to have as much of a difference there. So if it's dropping straight down in, you can scribe that line. Once you have it pretty much outlined, you could even do this with a Sharpie at this point because we're not doing our final cuts. And what you want to do is just, I call it rough cut. Just do a rough cut of the bottom of the door so that way when you put the panel over, it has the right distance upward. I'm even going to cut the bead off, not to the exact center, just shy of it. And then I can slide this thing up, removing a little bit more each time on the edges. So that way the body line I can get to line up on either end and I know nothing after that point is going to move. Now the bead roller is not going to put the same profile in the very edge of the bead like a Pullmax is going to do either. Because it's stretching the metal and a bead roller is only forming, you end up having to coin, and there are tools for coining the bead. But again, I have corners of the door that are not affected. And if they're not affected, I'm just gonna cut them shy of that area and I'm gonna put my patch in to where I can just weld it and then we can leave what's existing factory looking. Once you creep up on exactly where you need the bead to be and you have the fitment where you need it to be, you can use Dykem layout fluid, or if you guys can see your scribe good enough with your surface that you have, you are going to want to use the scribe. The scribe is going to give you such an accurate measurement that you can then grind up to it. If you have a lot of material to take, you can shear it off with hand shears. You can use a 36 grit on a roll lock. And when you get close, I would suggest switching to an 80 grit on the roll lock and or a file. If you file it, the whole thing here is you're going to spend the majority of your time fitting the panel into place versus the amount of time it's actually going to take to weld. And if you don't take the time to fit it where it needs to be and have a very good fitment, you're going to battle the welding the entire time. The gaps is always the #1 hardest thing when it comes to actually fitting a sheet metal panel in. It's a lot different of a battle when it's a frame or a chassis. Once you have the bead completed, everything is cut and you have refined it into place, you need to tip the distance from the lower bead line to the very edge of the door. We need that edge to be folded under at the very end, and that is going to be the last step of the door, but we have to account for that flange. We are going to be using the bead roller with a tipping die. That way we can do a very slight arc. Once you have the bottom edge marked for that distance, I use a straight edge and I just scribe it across, and then we are going to run it through the bead roller, tipping it. You don't want to run it through the bead roller all at once, forcing all that pressure. Sheet metal wants to be worked through a little bit gradually at a time. So it might take you several passes with the bead roller to get that flange to tip out. At this point, we're really only looking for about 90 degrees because we still have to replace all of the inside of the door, and later on we will be working that flange back around. After you've got the panel tipped, if you need a sharper edge, you have the ability to take a toe dolly on a bench and hammer and dolly that against that nice square edge to crispen anything up. If you're off a little bit, you can even use that toe dolly to move that bead gradually on one end or the other if you have a slight radius. We have used these separators to get our exact measurements from bead to bottom edge. At this point, we no longer have to worry because the bottom of that bead is going to be lined up exactly with what we have existing. There was a little bit of damage on the bead that we needed to correct before we jump into welding. We're going to be using these T-dollies. Those T-dollies will also match just like we used on the bead roller to get the profile that we need. It doesn't matter if you guys are using a piece of hardwood and you shape it into there with a die grinder, whatever gets you back to the shape that you need, that you can stick it behind the bead and then remove all of the damage. Now, because we have to do some welding on the bead, that raises us up farther into the door. In order to remove warpage later in this video, we have to gain access. In order to gain access, we're actually going to cut back of the door off just above where we're going to be doing our welding. The welder that we're going to be using today is a Miller Dynasty 200 TIG machine. That particular welder has a max amperage of 200 amps, hence the 200. We're going to be setting it specifically for sheet metal. So we are using a number 20 torch with about 20 CFM coming out of a gas lens. In the gas lens, the collet size, we're going to be using a 1/16. Instead of the 3/32, you're going to find that the arc is a lot more precise with a 1/16, and it stays and keeps the heat a lot smaller, a lot more concentrated right where you need it. The number one thing is for every 1/1000th of an inch, you need to be setting the sheet metal thickness is directly correlated to the amperage in the machine. So if this panel is 45 thousandths of an inch, you are going to be setting your amperage at 45 amps. That way, when you pedal down on the TIG welder, you are able to accurately feed the rod, and you're not going to get any more than that 45 amps. Once you have the welder completely set up and you are ready to tack it into place, you also want to make sure that the alignment from panel to panel is exactly flush. If there is a little bit of a lip there, it becomes a little bit more of a struggle when you are trying to hammer and dolly that into place. So if you can tack weld everything where it needs to be, you're going to not fight it as much in the end. I would say start on one end and put it tack, so that way you can align it. Now, if your panel is slightly off and maybe it's wide, if you start to tack, the weld itself is actually going to shrink. It's going to heat up and expand, and you will see your gap get bigger. But as it cools, it will then close up and it will shrink, and it's gathering the metal into that area right where the weld is. And this is where you get all of the warpage. It is very important to make sure that you have removed all of the damage in the sheet metal before you weld. That way you know where the warpage is coming from. I think it's a misconception on people weld a panel in and then they chase the warpage in areas that don't need to be chased. If the panel fit good before you welded it, all you have to know is that you have to stretch out the weld to get right back to the fitment you were in. You want to be tack welding every ½ inch. Doesn't matter if you are MIG welding or TIG welding. That way the panel does not have anywhere to go. It is held in place, and then you can use the TIG welder to run from one end, continuous weld, and try to keep your heat affected zone very small. I like to try to keep it around 1 inch wide from end to end and try to run it as much of a continuous bead from one end to the other. The reason that that is ideal, even heat in is even heat out. What do I mean by that? We tack weld it across the panel and things start to move. So you end up with this whoop section across the door, and then we have to come back with the area that we're going to weld. So because we're doing it on the bead for the front side, we're going to use the T-dolly to put it underneath the tack weld, and we are going to lightly tap the weld and stretch the tack weld back out. What you'll notice at that point is that where you had the whip section and it pulled in on all those different areas, it's going to relax the metal right back to where you started. Now you have the ability to do the continuous weld because you have such a nice fit. And if you keep the heat even from one end to the other, it makes it much more easy to just hammer evenly across that bead and work out that warpage. If you can get the heat going through it even, then it's much easier to remove all of that warpage at the end evenly. We're using a T-dolly in the area that the bead is, but what do you do on the outside areas that are not in the bead? Because we do have the perimeter that goes to the very end, a couple inches on each side. You're going to match the dolly with the shape of the panel that you are welding. In this case, it is a flat door. We are going to use a flat toe dolly on the backside outside of the bead, and we are going to stretch that back out. If you have a flat panel and you weld it, it's going to shrink in like a V. You just need to hammer and dolly the same as you are on the bead, directly hammer on dolly, and it will stretch that right back out flat, and you can start grinding the profile of the weld down flush. We had to, number one, remove the entire back of the door just above the bead, so that way we had access to be able to hammer and dolly that warpage out. That was number one. Otherwise, if it was just the bottom of the door, I could have left all of this in and just remade the bottom of the door. Now, we're going to be repeating how we got our depths of each one of the breaks for the shape of the bottom of the door. And then we are going to be using the sheet metal break outside to tip that first edge because it's wide open, it's just a flat piece, we can do it quicker. But you could use the side of your workbench with a hammer and dolly. You can use a bead roller. So we did the first one in the break, and then we did the next two because the beads are so close together where it breaks the panel. We set the depth with calipers for each bend, and then we're able to set the bead roller to the same depth to replicate that exact step. Once we stepped it, we worked it through the bead roller just like we tipped the flange on the front side and ran it back and forth a few times until we were back at 90 degrees each time for the bend. We did leave this a little bit longer because remember, we extended the door to fill the gap of the bottom of the cab. At that point, we had a little bit of cancer around the back corner of the door. And I think some of these simple things overwhelm people when it comes to making the shape. I don't want you to get overwhelmed. Just think about what shape you have. What do you have laying around your garage that is a very similar radius? In this case, we have a set of 3 T-dollies. We just matched the T-dolly to the corner radius of the door, and we set it up in the vise, and we just smacked it and bent that last little bit of the sheet metal bottom around to where it matched the radius. And at that point, it was just a matter of putting the panel in and rough cutting it out so the panel would sit in where it needs to go. Once we got it really, really close, we clamped it, we scribed it, and we made a very precise cut. And then we could just sit there and file it away. Once we got it to fit where we needed it, we just repeated that exact process with the TIG welder, tack welding every ½ inch and running right through. The nice thing was, because the T-dolly matched the radius of the bottom of the door, we were able to just set that entire piece back on the T-dolly and work out that warpage from it. Now, in a perfect world, we would love to be able to work the warpage out of every single area that we can, but dependent on your timeline, budget, that sort of thing, we don't have a ton of time for this project. We only have 5 months to do the entire thing in metal, body, paint, polish, and reassembly. We got to the areas that we could get. So we have this big access in the door where we could put a hammer and dolly, and as we welded it back up, we could work the warpage out of the majority, but there are areas down in here below the hinge that we just physically can't get to. And that's where it boils down to just trying to keep the heat out of the panel as much as you can. And that way you don't have as much warpage as you would if you just put a ton of heat into it. Before we welded it back into place, we sandblasted all of the interior of the door, and then we coated it with like 90s weld through. I kept it clean along the edges that I'm going to weld. That way with the TIG welder, it doesn't like any contamination or any even weld through primers. It wants a nice clean weld, so we made sure we used the strip disc. We prepped everything as clean as we could get it, and we went for it and tack welded the same we did before and continuous welded. After everything is completely welded in, the last thing we had to do was take a hammer and dolly and tip the edge of the bottom of the door all the way back in on itself to complete the factory look of a door replacement. We want this to appear factory as much as we can, even though we did lengthen it a slight bit. Most of the time you're not going to notice that tiny little change. These doors from the factory were never an exact fit to begin with, so small modifications like this is not the end of the world. Now that you have a general idea of what this repair takes, get out in that garage and tackle your rust repair. Let me know if this works for you, what you found that worked and didn't work. And if you have experience with this and you see something that we missed, please put it in the comments below so we can all learn together. If you guys want to see a lot more on this project, don't forget to like and subscribe. We got a very short time frame with a lot of different things we're going to show you with this project. We'll see you guys on the next video.